Welcome to this lesson, Introduction to Blockchain Development with Ethereum, presented by Coding Bootcamps. What makes Ethereum special? We're going to take a look at the Ethereum network and smart contracts. Here is some information about our instructor, and here is some information about other courses you can take. So what we learned so far was we learned about hashing, cryptography. We had a little introduction to smart contracts, first and second generation blockchains. So now we're going to talk about some things you can do on the Ethereum network. So Ethereum is a public blockchain with all of the benefits described in a public blockchain. It was first conceived by Bitcoin developers who wanted to take the blockchain to the next step of running smart contracts to take action on asset transactions and also to create applications. So Ethereum is considered to be an operating network, like previously discussed. Smart contracts are not legal contracts, but they are computer programs that can enforce the terms of an agreement, but they are the heart of blockchain applications. The Ethereum virtual machine is the smart contract runtime on the Ethereum network. The EVM is a bytecode compiler for smart contract programming languages. So what happens is you write your smart contract in one of the supported smart contract programming languages, and the Ethereum virtual machine compiles it into a bytecode. And then that bytecode is run on the Ethereum blockchain. So if it sounds like Java or .NET, it's the exact same idea. So developers write their contracts in Solidity, JavaScript, Viper. They are then compiled into a bytecode and then run on Ethereum. So the Ethereum network exists in a base of networks. So there's the live production network, and then there are several test networks currently right now. And you can also set up a private network for development as well. And you can install Ethereum software locally. If you go out and take a look, there are, again, several Ethereum networks. Most of them are test networks, making different tests such as consensus algorithms and testing different Ethereum additional feature testing. So we can see here, again, the live network. You can see the Robston and Rinkerby network, and then there's a private network, and there could be more than this. So a smart contract certainly has elements of traditional contracts. There's an agreement, and the contract is written in some kind of form. In our case, it could be it's written in a smart contract. There's a third party. It's either maybe a bank or a title company or a court, and then there's some type of execution on that contract. With a smart contract, it is peer-to-peer. So there's an agreement, a smart contract is written, assets are transacted, money can change hands, so that is the execution. And then the asset also changes hands. So here, if we take a look at this type of transaction, Sandy needs an outdoor light installed, and she hires Sam to install that light, and they agree to use a smart contract. In this case, we're going to use the escrow approach, which Ethereum can certainly do. Contracts can be written to take the escrow approach. So Sandy is going to upload her payment to escrow. And then as Sam completes certain conditions in the contract, he can get paid on those completed conditions. So a survey of the property needs to be done, and then a wire needs to be run. And after that wire run is complete and Sandy approves, Sam can get paid some cryptocurrency on Ethereum. And then once the light is installed, the remainder of the payment goes to Sam's account. So Ethereum smart contracts can be written in Solidity, Viper, JavaScript, many other high-level programming languages. No matter the programming language, they are all compiled to the bytecode through the EVM. And smart contracts are meant, again, to take events or actions on our transactions. So, and smart contracts manage Ether. They don't manage dollars or uh, payments in that way. All payments are made using Ether. Solidity and its competitors operate in stages. So first, the logic is built in the form of source code, and then the logic is based on some kind of business rules or agreement. Then there is compiling by the EVM. At this stage, that program can self-manage and use private and public keys. And then as it's executing, that contract can update the Ethereum ledger. So the logic development in a smart contract or distributed application works in the same way that other application development is done. So logic is developed, there's some kind of compiling or building. There is public and private key management, no question about it, for your payments. And then when payments are made, the Ethereum ledger is updated. On the Bitcoin network, the native token is called a Bitcoin. And on Ethereum, we call the native token Ether. Ether is subdividable. So interestingly enough, the subdivisions are based on the smallest subdivision called a way. And the order of magnitude of one way and one Ether is 1 quintillion, so 10 to the 18th. That might be easier to say. And here are some other subdivisions. So we go from the way, which would be 10 to the first, all the way to the Ether, which is 10 to the 18th ways. So there's quite a bit of subdivision that can be done here. And this does help shield us from the volatility of cryptocurrency. And just like traditional transactions, there are some fees associated with the work that's done. And any work that's done for us on the blockchain, there is a fee for it, a very small fee. It's called gas. Gas is paid in Ether, so you will need some Ether to conduct your transactions. Just as traditional transactions have some kind of a Ethereum gas fees will differ depending upon the transactions and how they're run. Users should not view spending gas as any different from any kind of transaction fee. So Ethereum is not considered any more expensive. In fact, it's much, much less expensive. But gas fees are paid in Ether, and you will need to upload Ether to your Ethereum wallet to run on the Ethereum network. However, though, other blockchains like EOS and blockchains like that, it's the same thing. Priority is given to those that have more of that network's cryptocurrency. So with EOS, the more EOS coins you own, the higher priority your applications are to run on the EOS network. So you can take a look here and get an estimate of transaction costs. You can actually see it output as well in your Ethereum transaction. If you have a blockchain explorer, you can actually get this information. So the Ethereum, so we looked at Ethereum's design and mission. We talked about some smart contracts, how the Ethereum virtual machine works, the Ethereum networks, and the operations of the smart contracts, the Solidity and smart contract programming, payments, and Ethereum and subdividing. Before we move on, let's take a quick look here at, we can see here a smart contract, and this is code here. And this smart contract runs, well, first let's compile it. So I'm compiling it into a bytecode. And if we look here on the deployment, this initially is not going to run on the live Ethereum network. It's going to run on a simulated Ethereum network that they call the JavaScript VM network. But you can pick others, but we'll stick with the JavaScript VM network. And if we look here, we have all these public keys here that they give us. And notice that each of these public keys is given I guess we can call it test ether. So we can conduct transactions. So you get this complete simulation of the Ethereum network. If we click deploy here, we can see that, oh, there's a little bit of gas that was paid. And if we take a look here, we can actually see the details of this transaction. You can see some way here that was part of the transaction. So let's view the assessment. And let's check our learning materials for some additional resources and additional training. So next, we'll do a deep dive into smart contracts. Thank you.